So hello everyone, thank you for joining the Backend Study Group session, part 2 about data engineering. For those who are new, welcome, and for those of you who are with us, thank you and good to see you. In today's session, we will continue part 2 of data engineering, data science, and ML. Can you go to the next slide, Madhurima? Yeah, so brief introduction about who we are. So at Women Who Code, our mission is to inspire women and excel in their technology careers. We want to support their vision and their efforts in their career progression and different roles in the technology industry primarily. About me, so I'm a senior software engineer at Madhurima here in San Francisco. I have been in the industry for 11 years now. Primarily, I'm doing backend engineering. Madhurima, our awesome host, can you introduce us?
Sure, thank you, Prachi. Hello, everyone. I'm Madhurima. I am a data scientist at Slalom, and I have been in the industry for a couple of years now. Before that, I was in academia, and I have a background in statistical physics and data science. So looking forward to our session today.
Yeah, do you want to walk through the agenda?
Sure. So to start with, Prachi will give a brief overview about what backend engineering is, and then I'll take over and we'll dive deep into the data science and machine learning engineering roles for today. As Prachi said, this is part 2 of the series. We did the data engineering part previously. Similar to part 1, we'll do some basic introductions, do similarities and differences between data scientist and machine learning engineer, and then go into what a data scientist or a machine learning engineer does in their day-to-day life and the tech stack used.
Wonderful. So yeah, a quick intro about what backend engineering is. So backend engineering is something that the front end of the users do not see, right? It's everything behind the scenes, which is somewhat a black box for front end users, right? So all the server-side applications, microservices, REST APIs, we think about client-server architecture, we think about database engineering, how to design distributed systems. Some of the problems you want to solve is about data storage, performance, deployment processes, data availability, monitoring, service monitoring, and a bunch of other things. As we think about backend engineering, we want to also think about some of the core concepts of software engineering in general, which is software design, where what we think about is the high-level architecture, as well as small different modules that interface with each other and share and manipulate data. One way to think about this is you do software design either to solve a problem or you're trying to build a new product or a service, right? The first thing you would want to do is define the input, the output, right? Your data, business rules, right? On how you want to manipulate that data, and then the data schema as it evolves with respect to your application or your software evolving, right? Design patterns are some of the common solutions to some of the design problems. Think about design from a very high level. It would be UI design, which is how do you present data to the users, data visualization and the presentation. Data design as in how do you actually represent data internally, and how do you store your data, right? And process design is transferring data, validating the data, manipulating the data through different system interactions. Can you go next slide? All yours.
Thank you, Prachi. So a little brief introduction. So a data engineer basically builds and develops pipelines to bring all the data from different sources, different formats into one single place. Kind of think of it as unifying every multiple different data sources present, data formats present into a single data warehouse or a database so that it can be used by, let's say, some data visualization people or software engineers or data scientists any other end users from that perspective. It could be on cloud, it could be on premise, it could be a hybrid. So that's the basic task of a data engineer, is to develop those pipelines, design those pipelines, and make the data available for every other user. A data scientist now takes this data and tries to basically understand what the data is telling me. It could be finding patterns, it could be gaining more insights, it could be doing some kind of statistical tests, it could be building mathematical models or machine learning models to make sense of what more can I understand from all these data that is present. What do this data tell us? And a machine learning engineer basically helps or ties up the work of the data scientist to this bigger picture and helps design the architecture, the softwares to integrate the work of the data scientist and automate some of these processes that the data scientist has built to run on its own or by some API calls or some trigger. So that's the task of machine learning engineer. It's to deploy these models that the data scientist has built and integrate it with the bigger picture. And this is just the architecture diagram of how it would look from end to end. So on the left of the screen, I have all the data sources, and the data engineer would take all of these, put it in one single place, ingest it. The data scientist would take the data from there and then do some analysis, some data enhancement, some data enrichment, try to find out some meaning. And at the end of all of these processes is the user interface. It could be an app, it could be the website, it could be a presentation, it could be a dashboard. And after all this cleaning and massaging of the data, this is what the end user would want to see. So this is the entire process, and the data engineer comes in at the very first stage. And then there is an overlap between data and data scientist, machine learning engineer, data engineer in this process, and then goes to the end user. So yeah, as a data scientist, a little bit more focused, so you don't have to worry about collecting all the data from the sources. You already have it here in a consolidated form. It could be on cloud, it could be on premise. And then as a data scientist, I would take the data from these available sources, do some transformation, cleaning, analysis, enrichment, build models, depending on the problem. And sometimes a data scientist also has to develop the visualization piece, like what these models mean, what are they telling us. So some data scientists also have to, it's not always that this would be taken care of by somebody else, but after doing this analysis, you also have to kind of present it in a more visual or in a more in a form that makes more sense rather than just spitting out some numbers from the computer. So data scientists should be a little bit aware of this tools as well. And for a machine learning engineer, think of all these work the data scientist has done, but how do we integrate it with the bigger picture? And so a machine learning engineer's work is to automate this process, because as a data scientist, you can't be present 24 hours, 365 days looking after your models. That has to be automated in some process. That has to be integrated with the other work loads that is going on. So a machine learning engineer enables a data scientist to kind of push all of these work that they have built into a more production, and think of it as a more production environment, more in an automated fashion, and integrate it with the bigger picture. So A question for you all, how do you think then, they sound very similar to each other. So is there a difference between a data scientist and a machine learning engineer, or are there similarities? What are your thoughts? Thank you, Jana, for that answer. What do you mean? I'm going to ask you another question. Sorry. What do you mean by tech? Okay. Could you explain a little bit more? Yes, it is very much possible that in some roles, a data scientist will be doing the task of data engineering and vice versa. So it's not like there is a clear distinction, but I'll go through like wherein there is a more, like who does more of what, and what kind of skills you would need to go into, like if you want to be an expert in machine learning engineering, what kind of skills you would need versus a data scientist, what kind of skills you would need there. So there is a little bit of distinction there, but my screen. But they're very similar, and sometimes you have to do both. Like sometimes I do both. So yes, the difference is data scientists would be very much focused on the statistics and understanding the data and trying to figure out what the data tells you, and do a lot of data quality checks and run SQL queries, try to figure out that the data that is available for them to use, does that even make sense or not? A machine learning engineer would not do so much of the data analysis. Again, this can change, but this is a brief difference. They would be more focused on building pipelines, deploying it into, from dev to QA to prod, do a lot more of the build the pipeline model, a little bit of DevOps work. So how to integrate all of these with the overall picture. So that's not something data scientist would know off the back of their head, but an ML engineer should know all of these, like some of the DevOps rules, how to go from QA to production, all the CICD work that is required. So that's I would say basic difference, but yes, they do overlap in a lot of things, and they both work, I would say, very, very closely with each other because you're kind of helping out each other. So just to summarize, data scientists would be more focused on finding out and understanding what the data means. However, a machine learning engineer would be trying to integrate this work and automate the work so that the models can run without somebody, running it on a notebook. So making it more automated version. Okay, just a note. It is it is often used that we as data scientists, data engineers, machine learning engineers, we would be using a lot of pre-existing or pre-built codes or modules that is present. It is not that we don't write our own functions or our own softwares. However, it's not that we need to do everything from scratch. So you could see a lot of importing and making use of already existing softwares and packages. So this just an FYI.
Madhurima, before
Sure.
we proceed, there was a comment by Debbie.
Yeah. Yep.
Should we, let's
Yeah. Sorry, I missed the chat.
go.
Seems data scientist. That's a very good question. So yes, there are a lot of overlaps between a machine learning engineer and a data engineer, and they do work very close with each other as well. Again, as I said before, these three roles kind of overlap in a lot of places with each other. So you can't just work by yourself. I would not. Uh, the major difference, I would say, is as a machine learning engineer, you are not responsible for gathering uh, data and putting it in a data warehouse or database. So that task is solely for the data engineer. However, again, if it comes, then you might have to do all of the roles. So, but I'm saying as a machine learning engineer, you already get, I would say, unified format or data in a common format, in a common place, and you can take from there and work from there. So you are not responsible for going and collecting and formatting all of these data into one single place and putting it down in one single place so that everybody can use. But as a data engineer, that is your major task. You have to think about how to do it, how to load terabytes of data, or how to make it available so that a data scientist or an analyst or even somebody who is sitting on the UI side and designing a web interface can use it. So a data engineer has to worry more about how do I get it from different sources, and put it in a consolidated form in a database, but a machine learning engineer kind of works with the data that is available. Level of math competency that would be required to succeed. I cannot speak for a data engineer description. I would say it depends from company to company, the requirements and the roles. But yeah, basic knowledge is definitely required because, as you can see, these overlap. So it kind of depends on the role and the tasks that you are required to do. However, I would not say you need a PhD degree in math to do any of these tasks. So don't think that is required at all.
Yeah.
So yeah.
Just to add to that, at least from my observation and experience working with data engineers, data scientists, a lot of them do possess mathematics background, and they are really strong at like statistics and probabilities. That kind of adds to their role as a data scientist. But to Madhurima's point, you don't have to be a PhD or have a master's degree for it. It's just additional and it adds value.
Yeah. I would say knowing on the for data engineers and a machine learning engineer, knowing on the computer science side and the software side adds more value compared to a data scientist, where statistics and mathematical modeling and those kind of add more value. So I would say that's the trade-off. Okay, I got all the questions. And okay, so jumping into the life of a data scientist. So majorly, I've just tried to list out the things that we would do. So the major task is to convert a business requirement into a math problem, basically, or a data science problem, and then analyze the data and the data quality and kind of see what is there. And then comes down to the experimentation and building the right model, performing statistical test. And as I said, sometimes I would say majority of the times, also some kind of visualization technique. It could be simple simulations or plots, but it can get as sophisticated as building a web interface or a website or even a Tableau dashboard. So these are kind of the basic overview of what they do. And I'll go into each of them in detail. So before I do that, out of all this task, how do you think is the time distribution for, if somebody has to do, let's say there is a project and this is the end-to-end task, what do you think is the time distribution for each of these tasks? Yes, data cleansing takes most time, correct? Depending on the complexity requirements of these things. Yeah, that's a very that's a very correct statement. But even then, I would say here. Once we have figured out how I have transformed a business requirement into a data science problem, the majority of the time goes into analyzing the data and experimenting and performing statistical tests. And this is just an estimate, so don't take this number as like this is how much I would be spending all the time, but it's just an estimate. But as building the model, figuring out the data processing, cleansing, analyzing takes up the majority of the time. Coding in the notebooks is so much more simpler. Like it's once you have the data that you need, once you have figured out, okay, this is the problem and these are the models I'm going to use, and this is the model I can use so that it is more reusable. Once you have figured that data out, once you figured out, okay, what the data is trying to tell me, coding it is the most simplest part after this whole process. So yes, if you're building custom code, obviously it takes time. And if you're building modules that can be used, it takes time. But compared to figuring out what the data is trying to tell you, that is a much lesser time that is required. So it's just a thing. And yes, visualization, if the task is more focused on visualization, let's say you're building an app versus building a Python plot, yes, app would take more time, but even then your experimentation and statistical test and analysis of the data takes the majority of the time. Okay, why am I not moving forward? Oh God, is my screen frozen? Okay. Okay, so now the first task, and these are some of the questions that we get. There would be a requirement where somebody would say, we should give incentives to our regular subscribers so that they don't leave our platform. And that's it. Or somebody would say like, I need details on how we are spending or how we have spent, and I need to figure out my budget according to that, what products we are spending more, what products we are spending less. Or somebody would say, oh, I want to change the color of the app to blue, and I think it would be great because I think everybody likes blue. So this is kind of the problem that would come to us. And now, what do you think? How would you transform this into a data science question? Or how would you approach these questions? What would you do? You can pick any one of the examples if you like. I'll go through all of them, but any thoughts on any one of them?
Boy, it's a silent room.
A/B testing for, that is awesome. Yes, that is correct. We would do A/B testing for the second one. Okay. So let me start with the first one. Oh, okay, well, let me start with the second one since we have this answer for that. So there's something called A/B test, which you do. And for that, we would need to see if, but once you have boiled down that, yes, I need to do an A/B test, that's where after that, you'd go and start looking at the data and see if the data is even feasible to do A/B test or some kind of other test is required. But this is a very good example of a control group and A/B test, whether trying to launch, let's say, a beta version of something or a new colored version of something before even launching, because that requires significant back end engineering and lots of software people needs to be involved before even taking that decision. It's a quick way to test whether this would make sense or not, whether the customers would like this or not. So A/B test that's when you require to do A/B test. But for the first one, where somebody says, okay, I think we should give out some incentives to our regular subscribers. So if we know who are so we have to figure out from the data, do we know who our regular subscribers or users are? If we don't, then we need to classify these users, like who are the regular ones, who are subscribed, who are non-subscribed, who are just using it as is, who are premium subscribers. So we need to classify the users first. Then we need to figure out which features are more important for these subscribers. Why are like, what is that makes the subscribers stay on, and what are the features where the subscribers do not like, or it could be cost, it could be, I don't know, the color. What features is making us lose membership? So this is how, and each of these steps are kind of one problem by itself, and you need to figure out which model to use when, and if the data is there, what data to use, and so on and so forth. So this is the first task, is to kind of design your experiment based on what is the question. And for the third one, let's say if somebody says we need to figure out how we are spending because I want to forecast my future spending, it's kind of similar to like, where are we spending today? Do we have historical data for that? Do I need to do a time series? Or what kind of time series I can get for forecasting? Do I have a daily or a monthly pattern? So these are the kind of questions that I would need to ask. And once I have boiled it down to these questions, then I can go and get the data and then build the model. So building the model is the last part. Like that is, as I said, that is the most easiest part of all of this. Questions before I jump into this one? Okay. So the second part, which takes, I would say, majority of the time, is to analyze the data. First, what data is available? If I have enough data, if the data I have will do the job that I need to do. So let's say in terms of the A/B testing that I said, if we don't have the data on like blue is the right color or not, then I cannot do an A/B test. So then what do? Do I need to find out some additional data sources? Do I need to get some open source data? Do I need to ask the data engineers to bring in more data? So that's the first job we have to see after we have figured out what kind of problem we need. So let's say you want to classify your users, right? But you don't have a user database. Every user database you have is only subscribed users. Then how do you find out who are the premium subscribers or who are not subscribed users? So that's so quality of the data and what is the data available? Is are all the values or all the things that I thought I would get from the data, let's say all of them have so many missing values that I cannot find out any kind of patterns from there. What do I do then? So can I so data quality check issues, data formatting, even though the data engineer has brought in and consolidated all the data, as a data scientist, you would need to do lots of analysis and quality checks and cleansing and imputation and so on and so forth to figure out whether the data that is present that the data engineer has brought is going to answer the end goal that I am trying to solve. If not, then how do I do this? So that's the major portion. And then once I have the data, I have to figure out if I have qualitative data, that is it not numeric, like just let's say for the subscriber example, I have somebody's name and their and the price they have paid for the subscription. So that the name would be a qualitative data, and but if they have an ID associated with it, that would be a quantitative data, that is a numeric data. So if there is a price, that is a quantitative data. So what kind of data is present? Is it text data? Am I trying to go through some document and figure out what this document is telling? Am I trying to process some image data? And does that image data make sense? So once you have figured out all of these and cleansed all of these and analyzed it, that's when you can go in and to the next step of data, of building the model basically with this data. Questions on this? Sorry, questions on any questions on here? You mean, okay, I see a question. Don't have the data required. Sorry, maybe just a second up.
Hey, Debbie, if you can clarify a bit. Did you understand that, Madhurima?
I'm trying to sometimes drop the question, completely change. You don't have the data required. That happens a lot of times. There aren't enough resources on engineering to get it. Then, so I'll tell you from my experience, it's not always the data that is present in the database is sometimes not useful at all. So what we have to do is we have to either go for some open source data, or we have to go back and tell the team that the data which is here is not sufficient. So either we need to ingest data from XYZ sources, or we have this open source data which we can bring in right here. So maybe we can make use of that. Or if none of that is an option, then if we have to only work with the data that is available, then yes, we do declare that, yes, we can work with this data, but this will not answer the question that you're looking for. So if, let's say, for example, if I'm trying to looking for subscribers, but I don't have any user data, then that's either I get some user data from somewhere, or I cannot do any user analysis because I don't have any user data at all. So then we bring it up as a risk factor, saying, we don't see this data. If you don't give us this data, then we can't do this modeling. So you have to bring that up the sooner the better, because bringing in new data sources takes time.
Yeah, I have
Right.
a follow-up
Sure.
question to that, Madhurima.
Mm-hmm.
I'm just thinking out loud here. So let's say you have a Goodreads app, right? Where
Mm-hmm.
your database is storing your user information and
Mm-hmm.
their preferences and the list of books they are reading or
Mm-hmm.
read, whatever, right? So you can somewhat build like an interest profile for this
Yes.
particular user, right?
Yeah.
And that is some kind of analytics or some kind of modeling you can do with that
Yep.
kind of data, right?
Yep.
But
Yep.
for Goodreads doesn't need all the list of books ever
No.
present, right? That is
Yeah.
probably coming from something third party, right?
Yes.
That the list
Yes.
of books. So
Yes.
would it be beneficial for Goodreads as a company to also care about that third party data here as another additional data source for?
E- uh, it depends. Like if Goodreads wants to have their own, like as you said, they want to enrich their data by saying, yes, I want to have a collection of, all the books that is there, so that I can do more matching, as you said, and not just the books that is present in my database, then yes, let's say a third party source, they
Right.
would need to take into account of that. But if they say that, okay, I'm just going to do it for this product once, and I don't need to refresh it again and again, I can just call it maybe once in 2 years, then sure, they can call, they don't need to maintain it as is. They can just say, okay, I'm going to buy it from this third party data source once and build my model. And then,
Yeah. Yeah.
so yeah.
Yeah, because if they want to build some kind of recommendation system, right, based on some user
Yes. Yes.
profiles, then, like you said, they can buy the data once and they can keep considering that data is static, they can leverage
Yeah.
that for their
Yeah.
system, right? Or they always update their data from this third party
Exactly.
system regularly, but they'll still need to like persist it into their own database or
Yes.
systems
Yes.
and then do analysis or modeling on it, right?
Exactly. Yes. Because think of it. So that's where the data engine, they would like, whoever is playing the role of data engineer at that point of time, they would be like, let's say the third party data is in a slightly different format than ours. So if you want to ingest it on a regular basis, by regular, I don't mean daily, but on a regular basis, why don't we bring it such that we always, the third party is the source. I don't worry about that, but it's in a much more nicer format so that the data scientist doesn't have to always go and clean up and do all of this stuff, but it will be stored in a proper place where you can query it in a much more nicer form. So that's how everything kind of falls in place, if
Right,
that makes
right.
sense. Yeah.
Thank you.
No, of course. That's a good question and a good example. So yes, as Prachi was saying, the next one would be, you have all this data, you've cleansed it, and now you want to experiment and build your model. So let's go back to the example that we discussed. Somebody says we need details on spending and products and forecast. So we discussed, we need to first classify, let's say, the products. Like if somebody says, okay, what are these products? I don't understand what all of these products are. I want to know, let's say, which are my uh, uh, let's take an example of books, right? From Goodreads. Let's say somebody says, which are my fiction books, which are my nonfiction, which are my memoirs, which are, like, I need to understand how were we spending and in buying this book, like subscription or something. So we need to classify those, and then let's say I need to figure out a trend of, do customers read more fiction during holidays, or that's a myth that we think. So let's say some kind of trend we need to see. So how would you go about experimenting, or let's say building this classification model? Because that's the first task. Well, that's one of the tasks. It doesn't matter first or second. Any thoughts?
Maybe by the year, maybe by some kind of data point.
Would DS use Tableau to explore the data? Yeah, they can use, but I should warn you, Tableau takes a very, very nicely cleaned processed data. So that is not always the case that is available. If it is, then yes, go for it. But if you don't see that, then it might be an issue. It's directly with the product, their ideas of classify and what the hypotheses are, then test out some ideas. Definitely, you have to ask them how to classify that because it is there. Like if I just go to, let's say, I don't know, let's say if I go to a CPG company, right, and I say, oh, I want to classify it into the ways I want, they will not listen to what I want. So of course you have to ask them. But my question was more about like, once you know, okay, fine, I have to classify it into this, how would you go about from there to your final model? What are the questions that you need to ask before you open up your notebook and start coding? So let's move on. So again, the first question always starts with, is the quality good enough to start building a classification model? Is this a text classification problem or is this a number classification problem? Because if it is text classification where you're trying to classify a bunch of words, and by words I don't mean names or states, that is further easier versus classifying, let's say the example Prachi said, right? Goodreads. Let's say you have a bunch of books and you have to figure out from all of these books which one is fiction versus non-fiction. These are all words. So how do you classify that? So then that becomes a text classification problem, and then you have to tackle it in a different way. The next question is it a supervised problem or unsupervised? By supervised, I mean, can I provide the algorithm some examples of already existing examples from where the algorithm can learn and predict future ones? Or is it something that where I do not have example at all? And then what kind of classification models I have to use? The next question would be like, do I know what are the target classification groups, like fiction, nonfiction, memoirs, travel? Do I know all of these, or I am in absolute dark and I have to figure out, okay, I have this 10,000 books and I have to classify it into fiction, nonfiction, and I don't know, I can't provide these examples or these target groups that, okay, if you find, let's say, so and so and so word, it would be fiction. If you find, autobiography kind of word, then it would go into some section. If I don't have that, then I cannot do a supervised model. If I have that, I can do a supervised model. Now, if I have an unsupervised technique, should I do clustering? Does clustering make sense? Do I have enough data to do clustering? Or am I getting random clusters all over the place? And I don't know what those clusters mean. Do I need to combine all of them, or can I just stick with one? Is it just a yes or no, like fiction, nonfiction, and everything falls into this? Or do I have fiction, subcategory of fiction, and then subcategory of fiction? Or do I have like multi-level classification? And then the most important question is, I have done all of this. Me as a data scientist understand that, an ML engineer understands that, a statistics person understand that. But as an end user, how do I represent this model? Like, to the person who asked me this question, I need to see what products I am spending my money in. If I tell them, okay, these are the fiction books, how do I answer that question? How do I represent the model output to answer that question? So once I figured all of these out, and that's where all the experimentation about which model do we use, which is appropriate model, do I need to do some kind of statistical test? Do I need to use maybe a mixture of classification, non-classification. Do I need to figure out, do I have training data or not? That's another majority of time you would spend. And Prachi, I know you said that we could classify it with year. Yes, that is for the time series problem. That's where we would go with the dates and year. Is, let's say I want to see which year my book sales were higher versus what is the time when, like movies come out during holiday season. Why do all these streaming services put out movies during holiday season? Because they have seen that people want to watch them more. How did they find that? Because they have historical data. So they have, like, every user, let's say, has a spike, like watches more of this. So there is maybe a more view percentage of this, or everybody is ordering more holiday movies. So that's how they have known after analyzing this data on a year-to-year or month-to-month basis. So that's where time series kind of application comes in.
Absolutely, that's a great example. Thank you.
Of course, I spoke a lot, so I'll take a pause and ask if you have any questions.
Do we have some standard guidelines or like a template on, this is how we do binary classification, or it all kind of depends on, what does your data look like?
It all depends on the data, what it looks like. So for binary, I would say classification, like if you just even Google, classification machine learning model, you'd get like 10 different models. Somebody will say naive Bayes, logistic regression, random forest, XGBoost, decision tree. I'm just throwing out names because if you just Google any one of them, you will get like 10,000 different articles. But the question is, which one of this is appropriate for the data I have and for the task that I am doing? Yes, all of them are math based, because at the end of the day, all of these models are very agnostic of what the question is, because this business requirement, you have to kind of look at the data and the business requirement. And yes, maybe you are getting 99.9999% accuracy with XGBoost, but it is taking, let's say, 7 days to train. And let's say you don't have that much time, or even predict, forget training takes more time. But let's say it takes like 1 day to give you a prediction, then that's not a model I would want to put it in production, because I want my predictions to come as fast as possible. So then I would go for something where it gives me an accuracy of 80%, but it gives me a result like that, like maybe in a second. So that's where you have to kind of sit with like the data and the ask and kind of figure out which is the best model and how do I represent this model outputs to answer the question that I have.
I see. Interesting. Yeah.
So yes, yes, definitely there are things like, I have to not overfit my model, or, take care of outliers. These are the basic rules. Yes. But even then, sometimes with the data that you're seeing or with the questions that you're seeing, it comes down to making a choice between, like, making the best choice for that particular problem. There is no just one answer fits all kind of a thing. How many projects? And another thing is, which I realized is, if you go on a course, or if you want to take a course, or if you even want to do sample data science questions, or even if you go to Kaggle, you will see very nice questions laid out for you and very, very, very nice data. That's not how you will get data at all in real life. So yes, those are good for practice and those are good to start, but please do not have this expectation. And this is true even in academia. Please do not have this expectation that the real data that you would get is as Like I can just drop 5 rows of missing value. That is not going to happen. You'll have like probably, I'm just throwing out some random numbers, out of 50 columns that you see, you'll see like 40 of them have values which do not make any sense. Like, what do I do then? I can't drop 10 columns of a like, or like 50 out of 50. Let's say I can't drop 20 columns, and I'll miss out on all the data points that is there. So that's when you think out how to work with whatever is present, or is it really that bad that I need to get some additional help? And even additional data will have its own complications. Question is, how many projects do you typically work on a quarter? It depends. Sometimes I would say it varies from company to company and from project to project. There's not a single answer to that. So it could be multi months. It could be just, if you're building something like a proof of concept, it would be very small and small time frame. But if you're building out, let's say from end to end some solution and digitizing this entire process, then that's going to take a much longer time than a proof of concept.
I have a question about like
Sure.
quality. You say, is the data quality good to start building a model, right? Like, how can we define quality? Like, basically, what is minimal to call it like this is something I can, like do something with?
Yeah, let's say I'm going to take a small example. Let's say you have a table and you have 20 rows in that table, right? And you're trying to build, like, you're trying to find just simple, you're trying to just do some kind of regression and predict what will happen in the next 2 months. And there's just a year of data, and you're trying to predict what will happen in the next 4 years. It's not enough information, because you don't, if you have only a year's worth of data, and somebody says, oh, I want to predict the next 4 years, it's not enough data. So then you need to say, I need at least last 5 years of data to kind of see a trend. But let's say if you're looking at Twitter, right? Twitter, if you collect Twitter, I have worked with Twitter, so I know this. If you collect 6 months of data from 2 million users, you will have billions of rows.
Definitely, yeah. That's a lot.
And that is enough given what you were trying to work. But let's say for automotive industry, if you're working in that, a problem in that automotive industry, any change takes years to develop. Like you can't just build an electric car like that. Like it took years to build it. So if you're telling, okay, I need to predict what will happen in the next 6 months, not much will happen, because it takes some time. So that's the quality I'm talking about. It's not just, dealing with missing values or what do I do that there are so many null values. There's always a way to figure that out, but it comes down to what kind of questions you're trying to answer with the data that is present.
It's relative to the problem and the domain as well.
Yeah.
Thank you.
Of course. Okay, so the tech stack is pretty simple. It's either Python or R or both, depending on the problem. Definitely some kind of SQL or NoSQL. Scala is always good to have, but it's not a requirement. But Python and or R, SQL, these are must. And definitely Jupyter notebooks or R notebooks. And very, very important is CICD, because you don't want to disrupt something, but you want to kind of keep on developing and integrating what you have done. So knowledge of CICD is important, because I'll tell, this will come very, very relevant the moment you're trying to productionalize this data, or productionalize your model, sorry. So CICD is important. If you know command line, that is awesome. If you don't, a little bit of it helps. If not, then most CICD, I would say, are trying to come up with a graphic interface model, sorry, interface version. But yeah, command line helps a lot knowing that. Okay, any questions for here before I move to MLOps? I know we are at an hour mark, and I did not think it would take so much time. Testing. Hypothesis testing, well, hypothesis testing is it's a very generalized and a very, very statistics related thing. I don't want to go into it because it will become very technical, but if you want, I can just reach out to me later on and I can tell you some resources. But yeah, statistical testing will come when, like, you're trying to kind of compare two things. Like, would you do a chi-square test, or would you do a z test, or would you do like would you do a Kolmogorov test? There are a lot of them, and depending on how your data distribution is, you would have to, again, it's the same way as choosing and building a classification model. There are so many hypothesis tests, and depending on what you're trying to answer, depending on what the data looks like, you have to decide on which test to use. So that is what Prachi was saying, that knowing statistics and mathematical modeling, computational modeling kind of gives you an edge, is because then you can kind of identify right away, okay, I know this, I am going to compare these two distributions, I'm going to use chi-square test. I'm going to compare these two distributions, I'm going to take this. So that's where it comes in handy.
Can I ask a quick follow-up on that?
Sure.
So I don't have that background. I wish I had that background. I wish I knew most of what most of you come in here with, but a question on that. So am I understanding this correctly, that you might change one thing and then take a look at the results from changing that one thing, and then you'll change another thing and take a look at the results? Is that kind of along the lines of what you do as an example of testing?
No. So when I mean testing, it's before you even start. So think of this example I gave, right? I want to change, okay, everybody knows Amazon. So now somebody in Amazon comes up with this idea that I want to change the color of the Amazon cart from present, I don't know, yellow to black. And because I think that will attract more customers.
Mm-hmm.
So now to test this theory out, test this hypothesis out, what we would do is we would make a version of the card which is, let's say, blue in color, and the original version remains as is. And then we would test this out with users and see if there is any change or not.
Yes, usability. I understand that. I have a lot of experience with that. Yeah.
Yes. So then when you're testing two groups out, so one we would call is the control group, is where you're controlling the situation, and then you do statistics on the data that you get from them, and then you can make kind of informed decision saying, yes, changing it to blue makes sense versus not.
Got it. Yeah. Okay. Got it. Yeah. Thank you.
PyTorch. I have used TensorFlow. I have not used PyTorch yet. However, these are just, again, as I said, these are already, TensorFlow is built by Google, so it's already there. The only thing you need to do is import TensorFlow and then do some, and then the magic happens. So that takes significantly lesser time. So, but if we are interested for Apache, I can maybe, not today, but we can think about it later on, because I don't have anything to show as demo today on TensorFlow.
Yeah, thanks for the question, Danielle.
Yeah.
Daniela. We'll think about this, and if there is something we can present or talk about in a detailed manner, we would definitely want to. So thanks for the question.
Yep.
I have another question from Debbie.
Sure.
People who are not passionate about a management career track, do you find that there are good career pathing opportunities for individual contributors?
Sorry, I have
basically in
no
these
idea.
roles, if you don't want to eventually go into like a management role, continuing to be an IC, what would it look like?
I should ask that question to you, because yeah, I'm just starting out in industry, so you would have more experience than me.
Yeah.
This one.
I think what I think of it in two ways. One is like solving hard technical problems, or which align or overlap with some of the domain problems, right? That the industry you're working or the company you're working in. Like, we are at good rates, right? We want more and more users to sign up. We want to give them excellent recommendations. They keep on using the product. That's a business requirement you need to solve, but you want to solve it through technology and a bunch of other things. So these are some good problems to solve. So that's what you will do as an IC. And the other thing would be, you have a new technology coming in, you have new tools coming in, you're constantly learning, you're constantly leveraging those tools and getting better and improving your system. So those kind of things are always there in the IC track if you choose to not try management at all. So you just keep on solving technical and product related or industry problems with technology, right? With newer concepts, with different kind of tools, different kind of products, stuff like that.
Thank you. Okay, so what is happening? Okay. So we went over this, but we're starting with ML engineer now, who would be automating all this process that the data scientist has done, right? So as an ML engineer, my task would be to design the pipeline to integrate the ML pipeline with the larger infrastructure. And another task would be to provision workspaces so that the data scientist can develop and deploy the models. And it sounds like you have to bring in new machines. It's not like that. It's just you have to create, like, let's say you're working on cloud or even on premise. These data that I'm talking about, if it is like, let's say a few gigabytes of data, you can run it on your computer, but is it safe enough? Who are the people who would have access to the data? Where are you going to store your results? So all these kind of things to make it data more safe, because the data scientist is not worrying at all about, where my data is getting stored, but somebody has to worry about it. I mean, when you're doing proof of concepts or when you're experimenting, you just want it to experiment and do it as kind of, I don't say as fast as possible, but you kind of want to do it quickly. But when you're trying to deploy it into a product, then you would need to think about, okay, I can't just save CSV files. I need to put it in a database. How do I put it in a database with the correct permissions? I don't want everybody to have access to this data, because as data scientist, you are actually seeing, and a machine learning engineer, you're actually seeing a lot of data about a lot of things. So you don't want everybody to see that. You don't want everybody to touch your model. Yes, you want the predictions to be there. You want everybody to see your outcome, but you don't want anybody to disturb that. So provisioning all of these takes a lot of, DevOps work. It takes a lot of software work. So that's where an ML engineer is an expert. And then the last task is to automate it so that a data scientist doesn't have to sit with their notebook open and kind of do this manually. But how can you make it automated so that somebody can call an API and do all this task? So basically, you want to automate all the experiments that the data scientist is, not all the experiments, the final experiment that you would want to implement. You would want to automate this task and also kind of integrate it with this pipeline that the data scientist is engineering. And you also want the output from your ML to go into the final user interface. So kind of matching this input and output is the designing that an ML engineer would do. And this is called the ML pipeline, basically. As I said, there are a lot. I already gave a lot of examples of provisioning that I was going to ask, but any more thoughts on what all is involved here in deployment and automation?
Maybe some kind of scripting.
Yes,
Automation.
definitely. Yep.
Probably
Very important.
deployment, even for deployment, right?
Yes. Extremely important, scripting. So yes, and that's where I'll go in detail into all of these, but think about, this is the thing that an ML engineer would be more focused on. So as a data scientist, you are done with your experiments, but now you need to kind of automate this process and deploy it. So you need to think of how the input pipeline will look, how the processing pipeline will look, and how the model pipelines will look. How will the output look like? You have to think about, do I need to retrain it? Well, this is not something an ML engineer would think by themselves or work by themselves. This is something that an ML engineer and a data scientist would work together, because when you're working on an example on your computer with a CSV file or an Excel file, you can do it, by yourself, but you don't want, you want the input to happen first, then you want the processing and the cleaning to happen, then you want the model deployment. You can't just launch a develop a model pipeline first before all of these happens. Let's say I need to update my results. I need to retrain the model. Some new data has come in, and the model performance is going bad. I need to go and check. So all kinds of things need to be taken care of. And each of these is by themselves another pipeline. And once all of this happens in the development space, then for deployment, you go to QA, and then you finally go to prod. And that's how you maintain it with the larger infrastructure, who is also going with dev QA prod. Again, a lot of stuff. I know, feel free to ask questions, but I'll try to make this as simple as possible. Again, so just, this is an example. Like, think of, I have done data cleaning, right? And let's say I have used as a data scientist two models to get to my final prediction. So everything that I have done in the notebook, now I need to put it in a script, because the scripts, as Prati said, scripting is required. That's how you would deploy it. I would put a script for data cleansing. It would contain the same steps as I did in my notebook, but now it's in a script so that I can run it independently. I would put all the codes that I wrote for developing model 1 into another script, and that would become a pipeline. Another thing is, you don't want your work to be like saved locally. So what happens is we want to register our model so that we can call the models often. And I don't have to go through cleaning the data and processing the data every time I want to run the model. So the best way is to register them as independent entities so that I can call them whenever I want to need it. Because let's think of a very simple example. Let's say I have built this Goodreads example, right? I have built this model where it will give me recommendations. However, to build the model, I have trained my model with, I don't know, let's say 10 gigabytes of data. If I start training it while the user is trying to get a prediction, it will take hours, and I don't want to do that. So I want to register my trained and final model as, okay, this is the best model which is going to work, and this would give me the predictions. So that's why I need to register the model so that I don't need to go through all the previous steps again and again whenever we have to make a call. The models, of course, the models are linked to the data. The models are always linked to the data. You can't build a model without the data. So, but you are kind of making all the steps independent of each, not really independent, but think of it like, okay, I get the data input and I have cleaned it. So I am going to build a cleaning pipeline who will only do the cleaning. And once I have cleaned it, I am going to put that cleaned up data somewhere and store it, so that when I will be doing the modeling part, I will only be calling the clean data, and I won't go through this entire process of input, processing, cleaning, analyzing, and then saving. So now when I'm building the model, I will always call only the cleaning data. And once I have the cleaning data ready, I train it and I see, okay, this model is giving me 80% accuracy and this is the best one I want. I save that model. So think of it as saving your work at each step so that you don't need to start from the scratch every time. But it will always be linked to, like all of these are linked to each other. It's just that you are kind of separating these steps out and saving it at each process so that it's much more easier to deploy and much more easier to call. And nobody has to sit there and say, okay, this is step one, this is step two, this is step three. You are making all the step one, step two, step three, you're making it into a script and a nice pipeline so that it runs automatically. Okay, did I skip anything? Okay. So this is how, again, this is an example I took from my work. This can change and will change depending on the project, but this is, I would say, one of the best practices that I have seen is when so ML engineer is working closely with DevOps person and the data engineering person. So they will have a directory of things where they will put all of these codes or scripts. And generally a structure looks like this. And these are, I would say, again, best practices. It can change or not change depending on what the requirement is. So, and I'll go through each of them, so don't be overwhelmed. So basically you want to have a section for your CICD so that you can develop in a continuous manner and integrate it in a continuous manner. You want to put all your experimentation that the data scientist has done somewhere. You don't want to lose it. You want to always keep it, but you want to separate it out from the other structure. You definitely want to have an infra folder where you'll have all the DevOps file. And why am I saying this? I can just go on and then do some testing. And these two are something which is extremely important, and I'll go through them in detail. But you'd have an MLOps package folder and the workspace, and this is where all the magic will happen. So, okay, it moves when I want it to move. When I don't want it to move. Come on. Yes, thank you. So CICD would be your all configuration files. So think of it as setting up your dev environment, QA environment, and your you have to always go from dev to QA to prod. So all of those configuration files will be there. Setting up those environment, all the requirements that are required, like access, key vault, etc., all the things that I don't honestly know of, but all the files would be sitting there. And this is where a DevOps person and the another folder, you'd work closely with them as well. The next is experiment. And this is where you would keep all your notebooks or all the experiments that you have done. And because you want to keep a track of that so that later on going through scripts is not so easy as going through a notebook. So you would want to keep those notebooks for reference. Infra is where all the DevOps file will be present. It will be infrastructure at code kind of situation. This will make things more faster rather than manually going through each and every step. So this is the place where a DevOps person, you'd work with a DevOps person very, very closely to kind of figure how to set this up. Integration test is where you would put all your scripts and files to make sure that the ML pipeline is working all together well with the data input and the data output folder. So sorry, data input and the data output pipeline. So that's where you will put all the scripts to test those integrations. Basically, so that this is, you don't want the machine learning model or whatever the statistics model that you have built to be standalone. You want everything to be nice and smooth and all connected. So that's where you would put all the test scripts. So ML ops would have all the unit test cases, very important before you deploy it. And as I said, we do build a lot of, let's say, custom packages or modules or functions that are used by anything that is used by the model, which is not just, importing from Spark or importing from pandas, which are inbuilt in the environment. Everything that you have custom built will go in this folder. And all the unit test cases, before you deploy, make sure you have test cases that you can go over and files so that you don't run into issues after deployment. And workspace is, remember all the steps that you did in the Jupyter notebook. Now you have converted them into scripts and you put all of these into workspace. Oops. And you make sure that all of these would run in a connected way. You have files so that you can do API calls, or you can, you can basically do API calls and use endpoints to run each of these steps. So everything that was in the experiment folder, now you have broken it up and you have put it in workspace folder. And I'll show you a little bit more about the structure because I know about this one and this one, but I'll just focus on the structure. So the workspace folder, generally you would have like a structure which would say pipelines. And under pipelines, like you would have one pipeline for, like, let's say data input pipeline, data pre-processing pipeline, data model pipeline. So that's what I mean by pipeline. Like you would have this structure for each of these pipelines so that it's becoming more automated and becoming more structured. And you are kind of eliminating this person from in between. Okay, so this is just to give you an example of what would be present in each of these files, right? What are each of these files for? So deploy as endpoint is a Python script. Basically, you write a Python script where you write the code where you would tell how to run. Let's say I'm writing this for the predict pipeline, right? Just as an example. So deploy as endpoint.py. You can name it anything you want. I just like to name my files for what they do. So this is just my convention. So I would want to write all the scripts that I would need to run the predict pipeline as an endpoint. The run pipeline would be, I want to run my predict pipeline using command line and all the script that is required there. This template is a very generalized version which you would replicate throughout, like predict or let's say model output or input. So if it is for predict pipeline, it will have an endpoint.json file, and this file will have details on what are my input output parameters, what are the steps I am following. It's a JSON file telling you all these string values. Again, I'm trying not to go into too much technical detail, but I'll show you an example of how the JSON file looks. Requirements is a text file where you would kind of list out all the predefined functions or libraries that you're going to use. Let's say you're using scikit-learn from Python. So you would say, okay, I would need this version of scikit-learn. Let's say you're using pandas. You would say, I would need this version of pandas. So all the requirements that are required to run a model or to clean the data, everything will go in the requirements. And script is the code that the data scientist was using on their notebook. That is the code that will go there. So it will contain all the steps that were done. Okay, for cleaning, let's say you took a bunch of columns and then you took a bunch of rows and imputed their value. You found the mean and then cleaned up and you rewrote the name. You changed the format. So all of that would go here. And as I said, you need to set up the workspace as to what kind of data set you need to use, what compute resources you need to use. So that would go in workspace JSON and workspace pipe. So I know this is a lot, but this is basically, and I said I'll show you an example of how the JSON file looks. So this is basically how the JSON file would look. This is an example from workspace. So let's say I am going to name my environment, this, and it would be some kind of ML workspace. And whether this would be a dev environment or a QA environment, you kind of specify that environment. You tell where the data was stored, what environment you're reading the data from. They will definitely have attribute because this is data storage. So is there a keyword? Sorry, is there a key to access it? What is the name of that account? Was the data created if it was not existing, or should I create the data it was not existing? So all of these parameters will go in here. Should the data new, if I'm going to save it, should that be put in dev or QA and prod? Which one you want? Now I'm moving next to the ML environment. What kind of packages can I just install using pre-built function? What kind of custom functions I have built? What are the paths to that? So think about it, all the information that I was just typing out nicely in a notebook. Now I need to make it not in a notebook because I'm not going to be present to run that. I need to make it in a script so that all of these can run by itself when I call this file. And if I want to be more So you can get as customized as possible. You can specify your resource, like compute resources. You can say how many nodes you need. You can say, do you want, a 2 GB RAM or an 8 GB RAM or a 64, or you need a GPU. You can go crazy with customization as much as you want. But this is what an ML engineer would do, and they're more knowledgeable about it versus a data scientist. And yes, sometimes you have to do both. I have done both, but like they are more knowledgeable about creating this thing, and I had to learn a little bit from there. So that's a basic difference. But this workspace, I call it workspace. You can name it anything else. Again, these names are something that I name my folders and my files. You don't have to stick to this. This is not something that everybody maintains, but you can call it anything you want, or depending on the project, there could be already existing names, but this is just an example I thought would be useful. So with that, with the tech stack, and I know there would be probably questions and I'm ready to answer that. I'll try my best to answer that. But as you can imagine, requiring Python and SQL, again, same for not so much of SQL, but more of Python. Again, if you're deploying it in R, then yes, you would need to know how the R notebooks look. But shell or bash scripting, definitely, and definitely command line work. You have to be much more proficient in command line and shell versus a data scientist or a data engineer. And that's the end. And I have listed out some resources here on Azure, AWS, GCP. Somebody wants to take a look at it. There are some free online resources that somebody has listed out, which I found was useful. There is an ML Ops infrastructure page if you are interested to learn more. There are certifications, and there's so many things to learn. It's just a lot.
Yeah, so the Slack link that I sent, Madhurima is on in that workspace, so you can reach out to her outside of LinkedIn, the Women Who Code Slack channel, Slack workspace. Madhurima, I have a couple questions.
Go ahead.
So I think Debbie asked about management track, right? Is there a management track as such for because for software engineers, right? Engineering management, their job is to support ICs, do what ICs do. But for a data science manager, I don't know, what would management track look like, if at all? Because I'm not familiar with it.
I will get back to you with that answer. I am not familiar with it as well. Okay, I know that so for data science track, I would say there are lots of things you can do, and there are a lot of new things which are coming out. But if you really want to become independent, I would say just give your best shot and invent a new algorithm that would solve something fast. But I know for ML engineers, and since I've been working with them closely, every cloud is something which is new, right? So every cloud platform has got its own structure of how these pipelines would work and own rules for setting up their spaces. So that is something which, if you are aware, if you're proficient in all the cloud technologies, then that would be something really amazing. But cloud is definitely, because everybody wants to move. Well, not everybody, but there is a trend of moving, going at least hybrid, if not 100% in cloud. So cloud technologies are definitely upcoming.
Yeah. Another question is, we also have a question in the chat. Maybe you should answer that first. Jana asked, could you go back and show the tech stack again for the MLE?
Oh yeah, I
Yeah.
yeah, it's Python or again, depending on which one you're looking for, not so much of SQL, but again, you might need to do some SQL queries. I would say focus mostly on R, Python, shell scripting, CICD, working with DevOps. Like if you know DevOps, then that would be amazing.
Okay, awesome. So what I want to understand is like,
Mhm.
we at Metromile, we are hiring data scientists, data engineers, and when we talk to like potential candidates, they are curious about like what other teams does data science or data analytics team talk to, right? Like, do you have a team of software engineers that are building services and they're building databases, and we need to process the data? Like, do we connect with them? Do we? How do we go around like building different products with them?
Mhm.
Are there, is this rare or is this like it's
No, I would say again, like think of it as a data scientist, you are not really building a product per se as a software engineer is building or a software developer is building. You're just taking the data and you're making sense of that data. Yes, you can like
So I can give an example from my
yeah.
experience, right? Like we were building this new service and we are integrating with this different kind of data. And
Mhm.
like Goodreads example, right? You want to get the
Yeah.
data, you want to massage it in a way that helps
Yes.
us build a better product. But
Yeah.
in this example, we are reaching out to like data science and data analytics team on, do you prefer a certain kind of schema that works well for you?
Yes,
What
exactly.
are some of the data points that you would want to prefer that we store at us in a certain way so that you can integrate with our database and you get everything you want? So stuff like
Yes.
that. That's where
Yes.
they
Yes.
contribute to those decisions.
Yes, so that's the thing. Like if you think of this whole, like let me go back and show you, right?
Yeah.
If you think of this whole, I have to go back a lot. Sorry, if you think of this whole picture, right? Like
Yeah.
somebody would be working with this data. That, as you said, like what kind of data you need. Like think of a data scientist sitting literally in like this space, which is probably like 1/5 or 1/10 of this entire infrastructure, right? So yes, whatever they are building sounds amazing, but in the larger scheme of things, you need to work with everybody because they are not really building a product like a software engineer is. They will help the software engineer tell, okay, you can, if you add this new feature, it will become a more cool product. So
Sure.
yes, they have to work with the software engineer for that purposes, but they are like, as yes, some data scientists are amazing coders, I'm not talking about them, but in general that is not the expectation that you would know to build multi-threaded programming which would be distributed in all sorts of ways, and you can submit all these jobs right in a very quick and dirty manner. But as a data scientist, they would be just sitting with their own small environment and working with it. And but the whole process, like software engineers are much more advanced in taking the task and making it into a product which is more viable.
Right. Yeah. Yeah, for sure. I agree with you. Another question would be like, so at least at my company, or any company I've worked at, really, we didn't never had like a data engineer, sorry, a database admin or management team. Like software engineers write the code and the API, but this data team kind of builds the database schema and then the database system, and then they worry about caching and deployment stuff. That is what I and my team has done as software engineers. So it's a different scenario, but like, let's say if you have bigger companies have this, they have this like this database admin or system management team.
Exactly.
So how will they fit in with data science team or data analytics team or stuff like that?
I would say the admin team is not really
Like the design or development or management team.
Yeah, I think if you're talking about the admin team, it would be more related to the security of the data.
Right.
So like how and where to store the data and who all would have permissions to see the data.
Right.
But if you're talking about the design team or the development team,
Yeah.
then yes, they would come into account. Like, let's say designing even this, in the example I was saying, right, designing from here to automating this process. Somebody needs to figure out how that design will look like. Somebody needs to figure out the JSON file that I showed at the end, right? What kind of compute, going back and forth. Here, what kind of compute resources would I need?
Exactly.
Do I need a large machine? How long will that large machine, like, do I need a GPU versus a CPU? Yes, GPUs are fancy. They can do things quickly, but it's going to cost me a lot if it is running for like 24 hours. Right. So, that's the design part, that's the DevOps part. And then deploying all these infrastructure as code. If you want to, let's say, develop something which you want it cloud agnostic, let's say, or then you would want to develop it in Terraform. So that's where you need their expertise, that how do I build these files? So design, development, all of these, like, this is, I would say, if you want to do it in the bigger picture, which is most of the time, you need their help, because as a data scientist, I am not trained to know, which one to use versus the other. But somebody who is trained in that will be able to tell me, oh, you should not use this, but you should use that. This compute instance makes more sense. If you follow this design and try to merge it here, then this makes more sense, versus integrating it there might break something which we don't want to break. So let's say the example that we were talking about, right? About launching a new font size or a color for something. Sure. Yes, the data scientist says, yes, make it blue, because I can see that customers are liking it. But who is going to make that blue? Or who is going to put that into the customers? Who is going to make that beta version? Right. I am working on an abstract. I can only get that data when some user has worked with that data, and the user will work with that data when somebody has developed and built it and sent it to the user. So
right. Definitely. Yeah. Agree with you on this. Another question I have is around like PubSub, right? If you want some kind of event, event system, I'm just, I don't have enough information, so I'm asking you, like, would there be some example where some kind of event management or some kind of PubSub model would fit in? Would that align with what you were saying earlier about like data engineers building pipelines? Would that be something different?
I don't know a lot about that, but I do know that you can kind of code in a trigger file. You can kind of say, okay, so like, think of it, well, not data scientists will not do that. You have to work with the ML, like more of an engineer person, as to where, like, how would you place that trigger? Like, let's say you want PubSub example, right? Let's say you want to put in a code here somewhere which says, whenever my model accuracy goes down below, let's say 70%, I need to send out an email to the team, whoever team it is, that you need to update, something is wrong, you need to update your model. So that's kind of the thing where you can think of that, yes, I need to maintain my accuracy to a certain level, or I need to, let's say, new data has come in, right? And you need to retrain your model with the new data.
Sure.
So you can set up a trigger saying, okay, I have got, let's say, 1 GB of new data, and this is very important. So I need to call my data scientist to ingest this data and retrain the model and do this thing. So that's where I would say is an example where PubSub kind of a thing would be implemented in ML engineer and data science world. But there are other examples like
Sure.
you can use
This,
it.
yeah, here the use case is some kind of alerting system where you're doing your,
Yeah, exactly.
right? Yeah,
Yeah.
that's the example.
Yeah, it could be other, like, all of these, you can plug in any kind of alert, like mostly it would be alert. Like, let's say there is an error, somebody has forgotten to put what kind of, I don't know, like their password or something like that, and they're trying on different passwords. So yeah, so that's where the ML engineer, so that is why I said this is very customizable, and it's not that this is the only way to do it. You can do it according to your needs, and you can set up as many parameters you want according to your needs.
Right. Yeah, thank you.
Of course, I hope I answered this correctly to the best of my knowledge.
Definitely. That was really helpful. So thank you. Yeah. I always had this question I should have asked you before. I did not see any questions in the chat, and feel free to just unmute and ask if you have more questions. I'll stop the recording now, I think.